So we're going to talk about language here, and language is also one of those higher order processes that includes things like writing, speaking, and understanding words. Now, the Wernicke's area here that you find in the temporal lobe, it's involved in recognizing written and spoken language. If Wernicke's area is damaged, then individuals have difficulty understanding written and spoken language. What they will hear will just sound like jumbled words, just like blather. Or what they see will also look jumbled. So you can imagine then maybe conditions like dyslexia could be a disorder of the Wernicke's area because they might have difficulty with written language. Now, the angular gyrus nearby processes words we read into a form that we can speak because it communicates with the Broca's area. So Wernicke's area you find in the categorical hemisphere. This is why we talk about language as being like a left brain function. However, it's not always true. And in the representational hemisphere, there's a corresponding area that recognizes the emotional content of speech. So in the representational, we can understand emotional inflection of speech. If it's categorical, it's only producing speech or understanding speech. So you can imagine then that we all use a little bit of both, like understanding the emotional qualities of how we speak or understand how other people are speaking, as well as precisely what they're saying too. Now what we see then here, you guys, is basically the motor speech area, it's called Broca's area, as well as the Wernicke's area back here in the temporal lobe. Now what we're looking at here is a type of brain scan called a PET, or positron emission tomography. And what a PET measures is essentially glucose utilization inside someone's brain. So they use a form of like radioactive glucose, and as it's being used, radioactivity is emitted, and that can be measured. So if you can measure how much glucose a part of your brain's using, that gives you an idea of how active that part of the brain is, right? So if you look at this heat map here on the surface of the brain, if it's more red, that means it's more active. If it's blue and green, it means it's less active. So you can see that right here, the part of the brain that's lit up, what part of the brain would that be, you guys? Broca's or Wernicke's? Wernicke's, right? So is that producing speech or understanding speech? Understanding, right? So this could be someone hearing a sound or a word, right? Then what happens after they hear it, there's some additional processing about what they hear in the speech association areas, right? And then what can happen then is it progresses closer to the Broca's area here, and then they might produce speech as a result, right? So they can hear something. They might hear a command saying like, "What is your name?" Right? This parts of the brain lights up, or question, sorry. Say, "What is your name?" They hear the question, right? Then they think about the answer to the question, and then they actually produce the corresponding question by using their Broca's area and producing that speech, which is actually pretty cool. You can see this occurring in real time. Now this is actually it seems really neat because you're almost looking at how someone's thinking, right? But there's only so much we can say about what's going on in the brain with these types of scans. We can't precisely understand what someone's thinking just based on a very broad view of brain activity. But scientists are getting closer to actually, reading minds. We're getting closer to that reality, you guys. So maybe within our lifetimes, they'll have more precise scans where they can actually kind of look into your head and see what you're thinking about, which sounds kind of creepy. But if you think about it from the standpoint of trying to connect with technology, we can be better connected, which is interesting. There might even be a mouse in the future. You might just like hook yourself up into a cap and just look at a screen and control the screen with your brain, and you can move your cursor and stuff like that, which is pretty neat. Yeah.
I had a patient where he was able to just look at the letters on a keyboard on a computer, and it would translate on the computer into the words that he was saying.
Yeah.
But he wasn't actually saying them.
Yeah.
Not verbalizing them at all. He wasn't moving his mouth.
Yeah, it's pretty neat.
Yeah.
That is pretty crazy.
That's kind of similar to the machine seated one.
Yeah. And so cognition, you guys, is this mental process of awareness, knowledge, memory, perception, problem solving, decision making, information processing, and thinking. Together we call that cognition, right? So if you talk about someone's cognitive abilities, we're referring to their awareness, their sense of self, right? Do they understand who they are, where they are, and what time and place it is, right? So their sense of knowledge, which relates to memory, right? That's also cognition. Memory is itself. Perception, like their perceptual awareness, basically, how well connected they are to the outside world. Can they see? Can they hear? Can they taste? Can they smell? As well as problem solving and decision making. Information processing, which could be more like complex analytical thoughts, and just general thinking, together we call cognition. So when you talk about someone's cognitive abilities, that's what we're talking about, is all these things together. And there's association areas for this. So remember we talked about the association areas, which there was different sensory association areas in the brain. And these were involved with integrating lots of sensory input for more complex processing. But the major association area was the gnostic area. Remember that one? The GNOSTIC? The gnostic area is one of those parts of your brain that's sort of one of the seats of cognition, in the sense that it's association area of association areas. So you take lots of different types of sensory information and bring it together to form a more unified understanding of the world around you. Now, memory is a more versatile element of human cognition. It involves different lengths of time. So we have like short-term memories and long-term memories. And storing and retrieving this information requires higher order mental functions and depends on complex interactions between different brain regions. So what this means, you guys, is that there is no one place for a memory. Like, memories are more distributed across the brain because they relate to different things like contexts, right? All of our memories have a context to them, like a time and a place, smell, sights, sounds, and all these things are interlinked. So our memories are not like one specific part of your brain, but it's more distributed and linked with a variety of different content or sort of perceptual features. Now, brain regions involved with memory include things like your limbic system, your insula, and your frontal cortex. So remember, the limbic system was involved with emotion. So a lot of memories have an emotional quality to them. In fact, probably the things you can remember the best and the most are the most emotional parts of your life, right? Whether they're good or bad. You're gonna remember, those would be the most vivid memories because that involves your limbic system, which is involved with learning memory. The insula, which is involved with taste, right, is also involved with learning and memory. In fact, if you had a bad experience, what's a catchphrase we say?
Leaves a bad taste in
You got it. Left a bad taste in my mouth. There's a bad memory, right? So it's interesting that we actually have phrases to describe the parts of our brain that we use for learning and memory, which is kind of interesting. And so there also might be a weird association between things like taste and memories. You probably remember things better if you we're tasting while you're remembering it. Now, the frontal cortex, that's involved with storing memories as well. And this is the one that's involved with sort of things like processing of information, personality, morality, judgment, behavior. Now, we know there's different lengths of time we can form memories. There's a good chance that 3 hours ago, you guys remembered maybe something I just said 10 seconds prior, right? And that would be on the order of short-term memory. Now, thinking about maybe a week from now, you probably won't have remembered everything we just talked about today, right? But you will remember some, and those would be in the order of long-term memories, right? Where it's like days, weeks, months, years, indefinitely. An indefinite amount of time is long-term memories, okay? Now, the shortest of your memory, though, is called sensory memory, and there are associations that are based on sensory input, and it's an exact copy of what's heard or seen. So have you guys ever had a circumstance where you heard somebody ask you a question, and that a memory of that noise or like the sound kind of ruminates in your head, and then maybe several seconds later, then you hear it again, and then you act on it, even though they haven't said it for several seconds. Does that happen to you all? Okay, good, because it happens to me all the time. Like someone will say, "Hey, did you blah, 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 blah?" I'm like, and there'll be a couple seconds that go by. Yeah, so then I respond to it. That would be a sensory memory. It's an exact copy of what's heard or seen. Okay, it lasts for fractions of a second, or maybe seconds at the most. Now, sensory memories though can be consolidated or stored into short-term memory. And short-term memory is it's characterized as limited capacity and brief duration. It's not necessarily an exact copy of what's seen or heard, but you temporarily store information about what was perceived. Now, long-term memory can exist for limitless periods of time. You guys probably have memories of when you were a child, which, if you think about it, is kind of odd to think about considering it many decades ago. And so those would be long-term memories, which can be indefinite. And I think what would be really weird would be, over 100 and have memories of when you were 3, right? And that's sort of odd. And those would definitely be long-term memories, right? Yeah, that's a good question. Why do we forget, right? Why don't we remember everything? Well, the thing about our brain is we have a limited number of neurons and a limited number of connections possible So presumably we probably have a limited amount of memory storage capacity. Although there's some people who theorize that, based on the human lifespan, we probably have a limitless amount of memory potential. But you could describe it one way: is it's possible that we have only a certain capacity for memory. But also, we typically remember the things that are important to us, and maybe things that are also important for our own survival and existence, because not everything that we encounter is necessarily that important to remember. It might not be important to remember the exact number of blinds you find in every single segment of blinds on this window, right? Although you look at that, you might have a sensory memory of it, and say in your head you might know that there's maybe 11 in a series of blinds, right? But it's not significant in your life, and because it has nothing to do with what's important to you. So then your brain doesn't need to remember that. And so forgetting is actually an important aspect of our lives, because we don't need to remember everything. And if we did, our brains would be so full of useless information that it would be actually hard to think about anything. So forgetting is an important process. Or even think about forgetting of negative events in your life too. That way you can kind of preserve your own sense of well-being. Because if you remembered all the negative parts of your life and really focused on them, then you could be kind of sad, and your sense of well-being would be low. So that's a good question. Why don't I remember everything from childhood? Well, it's kind of a complex question, but hopefully that kind of addresses part of it. Now, working memory is used for temporarily storing and manipulating information. So if you're recalling a memory, then you're recalling it into your working memory, and thinking about it involves your working memory. So this whole flow chart here, as you guys, shows the whole process of information processing and memory storage. So let's see if you get a stimulus, and that could be like a sight, a sound, a touch. That information then is sent into the sensory areas of your brain, where we have sensory memory. Sensory memories only last for milliseconds to seconds. And if our attention is not drawn to that sensation, then we forget it, right? Like we don't remember everything we hear or see or taste or smell or feel. Now, if our attention is drawn to it, and attention would require us to think that it's important or necessary, if our attention is drawn to that particular sensory memory, then we can actually take that information and store it in short-term memory or working memory. And this lasts on the order of minutes. If you repeat this information over and over and over, you start to form new connections in the brain and strengthen existing connections in the brain to actually form a memory. And a memory is actually a physical connection in the brain that's formed. So what's really odd about our memories, you guys, is that although they're this nebulous thing that's unique and it's subjective to our own experience, they have a physical representation in our brain. So that memories are physical as well, although it is sort of nebulous and seems not physical. Because they have a physical representation in our brain connection patterns and neural networks, that means that everything that you've ever experienced and remember is now imprinted within your own brain tissue in some regard, right? Maybe not in a way that we typically think about imprinting of information. Like it's not going to be as simple as writing words on a textbook, right, or like notes, but it's there, it's stored physically. Now, if you repeat this short-term memory over and over and over and over, it can start to be consolidated into long-term memory. And consolidation is a process of forming new neural connections and strengthening existing connections. And long-term memory can last in the order of days, months, and years. But if you don't continually retrieve long-term memories, there is a process of forgetting. So this whole idea in biology, the brain included, you either use it or lose it, right? I mean, I can tell you guys that there's been classes I've taken. There's on my transcript, it says that I've taken a class. I don't have a lot of memories from that class, okay? Because it's probably been 10 years ago since I've taken it. I might even vaguely remember where I took the class or who my instructor was, because either use it or lose it, right? And that's not necessarily a good thing. It doesn't make me feel good, but but if you retrieve it continually and you think about these memories, essentially that's going to help with this process of consolidation, and you'll remember it better. I haven't seen that movie. But working memories, you guys, is this whole idea where you consciously recall memories. And this is where it's sort of actively in your consciousness. But forgetting is an important process. If we didn't forget, we would be burdened with an excessive amount of memories. It just would be overwhelming, actually. So luckily we do forget. We just remember the things that are important to us. So that's something to keep in mind, right? Like if we remember the things that we think are important and our attention's drawn to it, if you can start to like trick your brain into thinking that things are important, then you'll remember things better. So just something to keep in mind. Now, in terms of memories, you guys, the brain has to organize complex information from short to long-term memory. The process of converting from short to long-term memory is called encoding, or memory consolidation. And encoding requires proper functioning of things like your amygdala, hippocampus, and limbic system. So amygdala and limbic system are part of the emotional centers of your brain. And the hippocampus is involved with consolidation of these memories. So that memories that are stored better have an emotional component. So if you want to remember something better, get emotional about it. Whether it's good or bad, you will remember that better, right? Think about some of your more vivid memories. They probably were very emotional times in your life, right? Whether it was good or bad. Because those emotions could help consolidate the memories more strongly, and you have something to attach a memory to. If you just rotely try to memorize some information without having to attach that to a time, place, or emotional quality, there's nothing to stick it to, right? And so that memory won't stick as well in your brain, and you won't remember as well. But if you can attach memories or information to other things like where you are, the current time, place, other forms of sensory input like smells, sights, right, tastes, in that same period of time, you'll remember that information better. And I tried to apply this when I was taking anatomy, guys, because I was trying to memorize a tremendous amount of information, like the actions and origins and insertions of muscles. I had about 150 of these to memorize over a weekend. And I remember having like 150 flashcards of a lot of information and trying to memorize this stuff. And I was thinking, how can I remember this? So I'm like, I gotta get emotional about this. So I just started getting emotional about it. I'm like, yes! And it's like, not necessarily in a good way, more angry. It was like definitely, a lower point in my academic career. I kind of remembered it. Didn't do as well as I hoped I would have on the muscles, but hopefully, I guess it kind of worked. We'll see. Now, during encoding, connections from the amygdala and hypothalamus link memories to specific emotions. Normal function of the hippocampus is required for formation of short-term memories, and long-term memories are stored in association areas of the cerebral cortex. So if someone gets damage to their cerebral cortex, they might lose their ability to recall certain memories. Now, consciousness is basically just the awareness of self. So we all know that we are who we are, and we're all individuals, right? And we take that for granted, right? We take it for granted that we understand that we are an individual separate from the world around us, and we are a living, thinking, breathing, wanting, loving thing. But only you know that about yourself, right? Like if I built a robot to say that I am a living, thinking, loving, breathing thing, right? That robot's it can't convince you that it's conscious, right? It might, but only you know that you're conscious, because consciousness is the awareness of self, and it's a subjective experience, right? None of us can say that a rock is not conscious, right? Like a rock on the ground is not conscious. Only the rock would know that if it were self-aware, right? Obviously, we can't communicate with rocks, but it's just something to consider. But because we can communicate with each other, we can tell each other, hey, yeah, I'm a person, right? And so we can all say that we're self-aware, we're conscious. But it is an interesting phenomenon, though. When does matter become self-aware? There's a classic quote by Carl Sagan. It's like, we're all made of stardust. I'm just going to paraphrase it. I don't remember it precisely. Something about like we're all made of stardust, right? Like our bodies are made from the guts of exploded stars. And that at some point that matter came together to contemplate its own existence and admire the stars in the universe. And at what point that happens is odd and strange, and it's a rabbit hole. Don't go there, you guys. But it's just, generally we'll think about it as the awareness of sensation. By the way, this is what got me interested in neuroscience, which is consciousness. But talking about consciousness is like talking about religion, and you won't get any definitive and concrete answers. So it's easier just to move on. Now, consciousness seems to involve particular brain centers, like the reticular formation. Now, this reticular formation is a loosely organized core of gray matter you find in the midbrain pons and medulla oblongata. It has motor and sensory components. And the motor component of the reticular formation communicates with the spinal cord, and it's involved with regulating muscle tone. And this is one of those things that clinicians can look for to help identify whether or not someone may be conscious, right? If someone's someone's unconscious, how can you tell whether they're sleeping or they totally lack consciousness? Well, you got to look for different identifiable features, right? Although you're sleeping, you're not currently conscious, or at least doesn't appear that way. You can dream, which is a pure form of consciousness. But what you look at then are things like muscle tone, because muscle tone correlates with consciousness. If someone has absolutely no muscle tone and they're in a vegetative state, that suggests then that they're not conscious. Like although their body's there and it might be able to keep their body alive, it suggests that there's not a lot of brain activity. And that's a more indirect way to measure consciousness. It can also be as simple as just looking for brain waves, looking for any kind of electrical activity in the brain, because it's electrical activity that correlates with consciousness. So if someone's in a vegetative state and you're measuring their brain waves, you see that there's nothing happening for weeks, what that suggests then is effectively they're brain dead, right? And although their body is there, their mind is gone. So the person's gone, because basically, although we are a body and a mind, a lot of who we are is also just the mind, right? It's kind of interesting. Now, the motor component also assists in autonomic motor functions like respiration rate and heart rate. And the sensory component involves what's called the reticular activating system, or RAS. It's responsible for alerting the cerebrum to incoming sensory information. And this RAS, or reticular activating system, is involved with your sense of awareness and attention and arousal. So have you guys ever felt kind of groggy, where you feel like you're tired, right? Like you're not totally awake. You feel like maybe you're like in a state of kind of like sleep and sort of awake, somewhere in between, where the whole world kind of feels just weird, like a dreamlike state. Well, that's because your reticular activating system is not fully active at that point. It's not totally on. You're still waking up. So in some regard, you are kind of still like in a dreamlike state. And because the reticular activating system is involved with alerting the cortex of incoming sensory information, if your cortex isn't ready to receive that information, then that's why it seems like a dream, because it's not actually able to process all the sensory information it's receiving. Noises and sights and smells aren't going to be as vivid as they would be if the reticular activating system, or RAS, were fully active. Now, it's responsible for maintaining a state of awareness or consciousness. And so drugs that basically, knock you out, affect this reticular activating system, right? So that's kind of cool. So it actually can inhibit consciousness during surgery. So this reticular activating system involves your thalamus here, and it helps alert the cortex of incoming sensory information. So as sensory information is coming up, then you get sort of priming of the cortices here. That way it can activate these neurons and make them more able to process that incoming sensory information. Now, there are levels of consciousness that exist on a continuum, or a state of alertness. Like you guys may have felt this idea where you're kind of awake, but not fully aware of the world around you. Or maybe you felt hyper aware when you had like 6 Red Bulls one day, and you're so aware that like the whole world seemed really bright and vivid, and things just seemed really almost too intense, and you wanted to avoid too much sensory information. So obviously it's drug induced, but it's interesting.